Hello students, today we are going to do a little bit of an algebra review. We're going to talk about equations of linear lines and equations of lines that are parallel and perpendicular to different lines. So before we begin, let's talk about a couple formulas that you should have already learned in Algebra 1, but we want to go over them just to be sure we remember them. So our first formula we're going to look at is slope formula. Remember that slope formula is y2 minus y1 divided by x2 minus x1. And remember, we're getting these from the ordered pairs that we're given anytime we're asked to find the slope between 2 points. Remember that slope is always rise over run, and our x values are the run and our y values are the rise, so that's why we always do the y2 minus y1 over the x2 minus x1. The second formula we're going to use is point slope form. This is y minus y1 equals m parentheses x minus x1. And again, once we find slope, that is actually the m value. So whatever we find as our slope, and then our x1 and our y1 are substituted in for these two values. The x and the y over here and over here stay the same, so they stay as x and y, because our goal here is to get from a slope and a point to slope-intercept form. So once we solve point-slope form, we will actually get to slope-intercept form, which is our last equation that we're using here, and that is y equals mx plus b. So as you can see in the two formulas, we have that y and we have that x, which is why we don't substitute anything for those values when we are putting it into point-slope form. The m value, again, just like up here, is our slope, and then the b value represents our y-intercept. So that is where our graph crosses the y-axis. Alright, so a little bit of review. Write the slope-intercept form of the equation of the line given the slope and the y-intercept. So remember, slope-intercept form we just talked about is y equals mx plus b. So we need to know our slope and we need to know our y-intercept, which in this problem we're given both of those. So our slope, which is our m value, is negative 5/3, and our y-intercept is our b value. So all we're going to do is substitute these values in. So we have y equals our slope, negative 5/3 x, and then our y-intercept is positive 4, so we're going to have a plus 4 here. And that is the slope-intercept form of that equation. Alright, write the slope-intercept form of the equation line through the given point with the given slope. So this time we're given a point and then we're given the slope. So in this case we're going to use point slope form, and it's called point slope form because we need the point, at least one point, and the slope in order to use it. So we're just going to substitute our values in here. So we have y minus our y. Label these in case you forgot. So our y1 is 5, positive 5. Our slope is a negative 5 over 4. And then we have x minus our x1, which is 0. Alright, so to get this in slope-intercept form, we're going to distribute the slope. So negative 5/4 times x is negative 5/4 times x, and then negative 5/4 times 0 is 0. And then in order to get to slope-intercept form, we need to get this y by itself over here, so the opposite of subtracting 5 is adding 5. And we can't add it to the negative 5/4 x because it's not like terms. So we're just going to tack it on the end here. So our slope-intercept form is y equals negative 5/4 x plus 5. Alright, our next example, write the slope-intercept form of the equation of the line through the given points. So on this one we're given 2 points. Now, in order to write the slope-intercept form, remember we need to write it in point-slope form. So to write it in point-slope form, we need at least one point and we need the slope. Well, we have at least one point here. We have an x1 and a y1. We also have an x2 and a y2. So in order to find the slope, we're going to go back to our slope formula, which was that first formula we talked about. We have our change in y divided by our change in x. So we're going to substitute these values in. Our y2 is a -2 minus our y1, which is 5, divided by our x2, which is -5, minus our x1, which is 2. So -2 minus 5 is -7, and -5 minus 2 is -7, and this can be reduced. -7 divided by -7 is a +1. So now we have our slope, which is +1. We have at least one point, so we can use point-slope form. Okay, so we have y minus our y1, which is 5, equals our slope, which we found to be 1, times x minus x1, which is 2. Now, when we went to point-slope form, you could have also used the second point if you wanted to. It doesn't matter which point you use, as long as if you use this y and this point, then you have to use this y and this point, or this x and this point. So don't mix up your points, but pick one to use and go with it. Alright, so we're going to distribute the 1, and we know when we multiply by 1, it doesn't change anything, so 1 times x is just x, and 1 times -2 is -2. And then to write it in slope-intercept form, we need to get that y by itself, so we're going to do the opposite and add 5 to both sides. So we have y equals x, and then -2 plus 5 is a +3. So make sure you're watching those signs there when you're combining your like terms. So our slope-intercept form is y equals x plus 3. Alright, fourth example. Write the slope-intercept form of the equation of the line described. So our line is going through -1, 2, and it is parallel to y equals -3x plus 3. So we have this new term in here, which you probably heard before, parallel. So let's talk about parallel lines. I'm sure you can recall from last year, or maybe even earlier this year, that parallel lines means we have two lines on a coordinate plane that never intersect. So we have two lines that are going in the same exact direction, and they're never going to cross. Alright, anytime we have parallel lines, they're never going to cross, so that means they're going to have the same slope, because they're always going in that same direction, so they have the same exact slope. So when we're looking at this equation that this line is parallel to, we will have y equals -3x plus 3, and in this equation, our slope is a -3. So that means that we have our slope, and we have a point, so we can now write our equation of our new line using point-slope form again. So we have y minus our y1 value, which is 2, equals our slope, -3, times x minus our x1, which is a -1, so a negative and a negative make a positive. Then we're going to distribute the -3. So we have -3 times x, and then -3 times 1 is a -3. And then we want to get the y by itself, so we do the opposite of subtracting 2. So we have y equals -3x, and then -3 plus 2 is a -1. So that is the slope-intercept form of the equation of a line that is parallel to y equals -3x plus 3. And as you can see, in our new equation, we still have that same slope as -3, which that's a quick way to check to make sure that your lines are actually parallel because they have the same slope. All right. And our last one. Write the slope-intercept form of the equation of the line described. So it goes through point -4, -3, and then it's perpendicular to y equals -4x plus 3. So we have a new word here, perpendicular. So let's talk about perpendicular lines. All right, perpendicular lines means that the two lines are crossing. So we have two lines on a coordinate plane that are crossing. And the thing about perpendicular lines is that not only are they crossing, but they make a 90-degree angle. So anytime you have two lines that are crossing that make a 90-degree angle, they are perpendicular. When we're looking at a coordinate plane and we want to talk about their slope of their lines, in order for the lines to be perpendicular, or to create a 90-degree angle, the slope has to be opposite of each other. So if a slope is negative, then the perpendicular line would have a positive, and vice versa. And then they also have to be reciprocal of each other. All right, so for example, if we have a slope of -2/5, the line that is perpendicular to a slope of -2/5 would be a positive because we have to do the opposite. Reciprocal means simply that we are going to flip the fraction. So instead of the 5 being the denominator, the 5 now becomes the numerator, and then the 2 becomes the denominator. So the slope of the line that's perpendicular to -2/5 is a positive 5/2. Another one, a -3, a line that is perpendicular to -3, well, it would be a positive because we would take the opposite. And now remember, this -3 is technically -3/1, so we're going to flip our fraction and we're going to make it a positive 1/3. All right, so let me erase this real quick and we'll look at the example that we're given. All right. So our slope in our perpendicular line here is a -4. So if our slope is -4 and we want to find the line that's perpendicular, we want to look at opposite, so it's going to be a +4. And remember, this is over 1, so it's going to be a positive 1/4. And that is our slope. So then we're going to use point slope form because we now have our slope and we were given a point over here. So we have y minus our y1, which is a -3, so that becomes a positive, double negative. Our slope is 1/4 times x minus our x1, which is a -4, so that becomes a positive with our double negative. We're going to distribute this 1/4, so we have y plus 3 equals 1/4 x, and 1/4 times 4 is 1. And then we're going to get y by itself, so we're going to subtract 3 from both sides. So we have y equals 1/4 x, and 1, positive 1, minus 3 is a -2. So that is the slope-intercept form of the line, y equals 1/4 x minus 2. Again, when we look at that slope, just to do a quick check, we look at that slope and we see that it is opposite of -4 and it is reciprocal of -4. So that's just a quick check to make sure that our equation is on the right track. All right, so remember, anytime a line is parallel, that means that the lines never cross and they have the same exact slope. And anytime the lines are perpendicular, that means they're going to cross. They create a 90-degree angle, and the slopes are opposite and reciprocal.